I'd like to invite our next speaker, is Shibrigo. Yes, the professor is probably most present. He's going to present the paper, Fracture Mechanics and Care Growth Rate of the Crack in the Hardness and intervention of Weld through step.
Hello, my name is Alexander. In this, I will present fracture mechanics and sharp paper properties, crack in weld metal, heat affected zone, and base metal welded hardness steel. First part of this research was to get a good weld joint without cracks and flaws, and after that to investigate hardness level, mechanical properties, epoch energy, and fracture mechanics. Introduction of the weldability. In this research, we weld Protoc 500 armor steel made in Acrony, developed for construction of military vehicles. Microstructure consists of temporary martensite. Hardness level is of 509 Vickers. Chemical composition of this steel is a high hardness steel with, as you can see, high carbon level, 0.27. For consumable, I use obstinate wire. Obstinate wire has chrome 18% approximately, and nickel 8%, and mangan 6.29. This steel is, if I can say, difficult for a weld. Crack appears in coarse grain zone and fusion line, and especially for military vehicles, which military vehicle do always driving on gravel roads. We have a dynamic loading, and crack which can appear during welding can very easily propagate near the fusion line. So, and this research was very interesting to investigating epoch energy, fracture mechanics, and other mechanical properties. Welding. In this research, we use gas metal arcs welding. As I mentioned, we use a solid austenited wire, consumable. Welding. For welding, we use robot welding, special tools which made to prepare plates. Special tools we use for a position of the plates, and we use it for a cutting water jet device. Welding, as I mentioned, solid wire. Why we use of sensitive slags, interpass cleaning, and we wanted to increase productivity and to decrease hydrogen amount. Benefits of robot, test repeatability, reduce human factor, fine tuning, and process automatization. Welding. On the picture we can see how we prepare welding plates. We use a short circle transfer for a root pass, and for a filler recover press we use a spray metal transfer. As mentioned, we use a gas metal welding carried with argon with 2.5 carbon dioxide. Results. Radiographic testing performed on 5 welded joints in order to ensure repeatability of results. In the sample were not found cracks, porosity, and other discontinuities, and both welding joints created with class B. After testing, we performed a hardness test. First hardness measure was 2 millimeters from the top surface, and results are next. Change happened up to 40 millimeters measured from the weld center line, which is accordance with military standard 1185. Hardness does not exceed 521 Vickers, which is very important to get a good ballistic properties. After that hardness test we continue to measure micro hardness near the fusion line, and hardness near the fusion line, as we can see, is approximately from 417 to 440 Vickers. Microstructure. Weld metal has austenite with small amount delta ferrite. So figure 8. Coarse grain zone exhibit microstructure of the upper, lower bainite and martensite. Fine grain zone consists of a mixture of the upper and lower bainite and martensite, and over tempered zone, figure B, consists of composite of tempered martensite. Tensile strength results. All tensile strength, tensile result was higher than 800 megapascal. I could represent now 825 and 933. If I can say this tensile result was, if I can say, better than usually for austenite wire. Tensile strength is approximately 700 megapascal. We increase tensile strength approximately for 130 megapascal, which is very good. Usually armor steel is a weld with low hydrogen consumable or austenite wire. Austenite consumable, sorry. Low hydrogen consumable has approximately from 130 to 160 megapascal. Austenite wire has approximately, as I mentioned, 700 megapascal. So we now get almost tensile strength almost as a low hydrogen consumable. After that, we investigated impact energy. Impact energy investigated the base metal, fusion line, and weld metal zone. And results are the next. On base metal, we investigated a temperature of 20 degrees, 0 degrees, minus 20, and minus 40 degrees. In this research, I will represent only 20 and minus 40 degrees temperature. At 20 degrees, base metal has approximately 34 joules. Crack initiation has approximately 28 joules, and crack propagation energy approximately 5 joules. Fracture surface is a mixed brittle and ductile. At minus 40 degrees, total energy is approximately 30 joules. Crack initiation energy is 27, and crack propagation energy is 1 joule. Fracture surface is pronounced brittle ductile, pronounced brittle fracture. If we can say from this we can say that crack initiation energy is almost the same, but crack propagation energy is a decrease for approximately 4 joules. Heat affected zone. Heat affected zone, total energy is 75 joules. Crack initiation energy 45, and crack propagation energy was approximately 30 joules. Fracture surface is a mixed brittle pronounced ductile fracture. At minus 40 degrees, crack initiation energy is 27, and crack propagation energy is 12 joules. As we can see, fracture surface is a clear brittle fracture. We can say that on both, on crack initiation and crack propagation energy, significantly we have a drop energy. We have a 45 and 27, and also crack propagation energy is from 30 to 12 joules. After that, I want to point out that all crack follow the fusion line. As you can see, on all investigated temperature, 20, 0, minus 20, and minus 40 degrees. We after that did EDS analysis on fracture surface, this surface, to see whether crack follow on weld metal or on base metal. It's interesting to say that on 20, 0, and minus 20 and minus 40, minus 20, chemical composition is similar chemical composition of the filler material, which is 16% chrome, mangan 6%, and nickel approximately 7%. On minus 40 degrees, chemical composition is similar with the base metal. the end of the epoch energy, also investigating weld metal. At 20 degrees, we have total energies 84 joules. Crack initiation energy is 29, and crack propagation energy is 55. Fracture surface is totally ductile. At minus 40 degrees, total energy is 65, and crack initiation energy is 24, and crack propagation energy is 37. Ductile surface is also totally ductile. We can say that crack initiation energy is almost the same, but significantly drop energy we have in crack propagation. So from 55 to 37. After epoch energy, we investigated fracture mechanics. Crack position is presented on base metal figure A, heat effective zone figure B, and weld metal figure C. Fracture toughness of the base metal, fracture toughness is 86 megapascal per root. We can see this is usually fracture toughness for armor steel, for high hardness steel. For example, base plate 500 has approximately 120, which is better than product. But this fracture toughness is good for high hardness armor steel. Fractograph in base metal, cut-off position is presented in figure A. We can see borderline between fatigue surface and ductile surface on B and C, and we can see also stretch zone on B and C. Heat affected fracture toughness in heat affected zone results of testing by potential and compliance drop technique presented in A and B. Critical value of J integral obtained, as we know, by intersection of regression line and bottom line, and value is 355 kilojoule per square meter. Based on the critical J integral, fracture toughness is indirectly determined, and the value is 286 megapascal. Fracture growth in the heat affected zone, cutoff also present in position of the cutoff is presented in figure A. Also, we can see a border between the fatigue surface and fatigue surface and ductile surface, and also stretching zone in BC. At the end, fracture toughness results in weld metal. Results of testing is also presented by compliance and potential drop testing techniques presented in figure A and figure B. And critical value of J integral is also get by intersection of the regression line and bottom line, and the value is 355. Also based on critical J integral, fracture toughness is indirectly determined, and the value is 355. Fractograph of weld metal. Also, position of the cutoff is presented in figure A. We can see border between the fatigue surface and the fracture surface is ductile with the ductile linkers B and C. And then the conclusions. We can say that, and we saw that tensile strength be increased by robot welding. We get 830 megapascal, usually obstinate, and we can say that obstinate wire can get very good tensile strength. Epoch energy, we can say that base metal has a small drop energy between the investigating temperature. Heat affecting zone, we can say that we have a significantly drop energy in crack initiation and crack propagation energy between the 20 and minus 40 degrees. Also, we can say for weld metal zone, we can say that we have a significantly drop energy between the 20 and minus 40 degrees, especially in crack propagation energy. For fracture toughness, fracture toughness to base metal is 86 megapascal, and which is usually for a high hardness armor steel. Results of the calculation for a heat effective zone, we can say that triple fracture toughness of the base metal. The highest fracture toughness has a weld metal 4 times higher than base metal. And thank you for your attention.
On the diagrams, what it means V, millimeters, is it low line displacement or seam V? What it means V?
Where?
Yeah, yes, here. Yes, what it means? On the upper couple.
Axis-meter position. Movement. Yeah, open. Yeah, back open.
Yes, please.
Why you choose an austenitic filler metal?
Why use a very good question? Simple. Just to say.
And the comparison in yielding of base metal and the filler metal, which is the mismatch between?
And fracture toughness is 4 times more, so it's unbelievable.
Yeah.
Okay.
I will explain.
Yes, okay, please.
I will explain. Usually for a welding, for a high hardness armor welding, now we're using the, we can see that using the low hydrogen symbol. That's one way. And second way is abstinent wire. Abstinent wire have a very good, if I can say, properties. All hydrogen movement through this abstinent wire is very slow. So when you're welding, when hydrogen comes into weld metal, he very slowly can move to the fusion line. Very slowly. So that's the most important, if I can say, behavior of this type of the cylinder. Low hydrogen, when hydrogen comes into weld metal, he can very easily move to fusion line. And there is also, if I can say, rule that for a high hardness steel, maximum level of the hydrogen must be from 1 to 5 millimeters of hydrogen per 100. That's very important. So when hydrogen comes into, he will probably stay in this zone. He will not move to the fusion line. That's very important. So that's the way. Low hydrogen also, I also present, and I wanted to point out that we increase tensile strength from, as I mentioned, obstinate wire has approximately 700 megapascal. We get 830 megapascal, more than 833 megapascal. So that's very good. And as I mentioned, why we use obstinate wire.
Yes, so just sure. Do you know how big is, for example, this strength this mesh structure?
Yeah.
How big is it?
For a product, tensile strength is approximately 1,500, and 1,500. Yeah.
Okay.
And we have now tensile strength for this is 855, almost double, almost 2. But that's usually, as I mentioned, military vehicle go through the very uneven roads, and this can, if I can say, get all dynamic roads. We also performed in this. We also did fatigue testing in all zones. As we performed fracture mechanic testing, we also did fatigue testing in base metal, heat effective zone, and weld metal. The best results get this part of weld metal, and after that, also welding, if I can say, was very important was to get in this research So to see was to get 521 hardness in this position. So we get a good balance between the toughness and ballistic properties. We also perform the ballistic properties, ballistic testing in all parts of the welding joint, and heat effective zone was not proved to the heat effective zone.
Thank you very much. We have to